Hello, welcome to this new tutorial. In this tutorial, we are going to visualize the ST segment. So for the ST segment, you have to know that in order for you to understand the ST segment, you have the first point of the ST segment is the G point. The G point is the major point, is immediately after the QRS complex. So when you have a QRS complex like that, the junction between the QRS complex and the ST segment is the G point. It is from this G point that you measure the isoelectricness of the S wave. Is it clear? So you have to first evaluate the G point. Now from the G point, you can now visualize if the S wave is isoelectric or not. Now for the isoelectricness of the S wave, what you have to do is that you have to compare it with the P wave. Is it clear? If it is more than, if this wave is more than a 0.2 millimeters, if it is more than 0.2 millimeters, it means that there is an ST segment, a significant ST segment elevation or depression. I hope you're understanding. So, and you need to know that your reference point to measure is a G point. So what do I mean by that? Let's say that you have a patient with a P wave as such, then you have the QRS complex, then you have like this, and then yes, you have T wave. Is it clear? So let's say that you have this. Is it clear? So now you need to know that here is the PR wave. So let's say that this is the line of the PR, the PR interval. Is it clear? Now you need to know that in order for you to measure the distance between the ST segment and the PR interval, you don't measure as from here. No, it is wrong. Is it clear? If you want to measure the distance from the ST interval, the ST segment and the PR interval line to know the baseline, generally the PR interval is the baseline. Is it clear? So in order for you to know if there is an ST segment elevation here, you don't measure from here from the baseline. No, you start from the G point, and yes, that's why the G point is significant. The G point is from here to here. Is it clear? This is the G point here. So it is this distance here that you take to be the ST segment elevation and not this distance down here. Is it clear? And now if that distance is greater than 0.2 millimeter, it means that there is a significant ST segment elevation. Are you understanding? Now, contrarily, you have the P wave, PR interval, the QRS complex, and you have also this that goes down, and you have like that. Then you have your T wave like as such. If you have such, you just draw the baseline on the PR interval. Now here is not the ST segment. You draw it from the G point. Is it clear? Here's the G point here, directly when in contact. So it's this distance here, and if this distance is more than 0.2 millimeters, it corresponds to an ST segment depression. Is it clear? Now we have to know that the ST segment elevation, ST segment depression are different pathology that you have to visualize. Generally, in ST segment elevation for myocardial infarction, is going to be localized on two contiguous leads that have the same locations. Is it clear? And then it also has a convex elevation, a segment elevation. While in pericarditis, they are much more diffuse and they have a concave ST segment elevation. So those are the different elements that you have to know on ST segment. The next tutorial now is going to be